In the instrumental variable analysis that we did, we assumed that everyone had the same treatment effect, beta underscore EW, and in the main analysis we set this to 0. But in many applications we expect different effects for subgroups. And this makes it more subtle to find the treatment effects. So we're going to use the same method again to try to understand how to estimate treatment effects when these are heterogeneous. So first we're going to generate our own data, and then we're going to try different estimators to see whether we can recover the effects that we put into our own data. So the example that we consider in the notebook is that we have unemployed and they are being offered a training program. And we assume there are 3 types of unemployed. So there are compliers, which means that if they are invited to the training program, they will accept it, but if they're not invited, they will not go to the training program. There's going to be always takers, who basically always go to the training program, whether they were invited or not. And we have never takers. So these are people who do not turn up at the training, even if they were invited. Yeah, so they never go to the training, irrespective of whether they were invited or not. Yeah, so the instrument we have in mind here is whether or not somebody was invited for the training. And the thing that we're after is the effect of training on earnings. So we assume that beta is the expected earnings without training, and beta plus tau is the expected earnings with training. Yeah, so the thing that we're after is tau, which is the treatment effect. It's the increase in expected earnings if you attend the training. Yeah, so generating data in this case is a bit more complicated than we had before, because we need to generate data for the different groups. And because we do not want to sort of copy-paste code all over again for each of the different groups, we're going to try to program this using dictionaries. So first we define 3 different functions which determine whether somebody accepts a training invitation or not. So we have the function accept complier, and invited is going to be a vector. For all the compliers in the group, it's going to be 0 or 1, where 0 means the person was invited for the training, and 1 means that the person was invited for the training, and 0 means that the person was not invited for the training. And compliers basically follow the invitation. Yeah, so the return here is what the function returns is this vector invited again. Yeah, so they go for training if invited is 1, and they will stay away from the training if invited is 0. The group always takers have a different acceptance function. So this is the function accept for the group always. And they always go to the training whether or not they were invited to this training. So what the function returns is basically it's always a 1. And we use this numpy function once like, which returns 1 with the same dimensions as the vector invited itself. Yeah, so if the vector invited is a column vector with 20 entries, then np ones like is going to be a column vector with 20 ones in it. Then for the final group, the never takers, we have this acceptance function accept underscore never, and they basically never go to the training. So here we have zeros like. Yeah, so it's another numpy function which returns a vector of zeros with the same dimensions as invited has. So to get our data, we're going to simulate 10,000 different individuals. So the number of simulations is going to be 10,000. And we're going to assume that 20% of these 10,000 are invited for the training. Then we have a list of types. And the list is going to be complier, always taker, and never taker. So later on we're going to loop over this list. And this is one of the advantages of Python, that it can basically loop over any list. So also a list of words, complier, always taker, never taker. Yeah, so we don't have to loop over 1, 2, 3, and then we need to remember that 1 was the complier, 2 the always taker, etc. Here we can simply directly loop over the names of the groups themselves, the complier, the always taker, and the never taker. We define beta as a dictionary. So beta is the effect of earnings when you do not have training. So we assume here that if you are a complier, the expected earnings that you will have without training are equal to 1. If you are an always taker, so these people are sort of very eager, so even if they do not have training, they're going to work very hard. So we assume that their expected earnings without training are equal to 2. And then we have the never takers, and their expected earning without training is going to be equal to 1. Then the treatment effect, so this is the effect that we actually want to estimate. So tau, again, is going to be a dictionary. So later on we're going to call tau with a key, and if the key is complier, tau will return 3. So for compliers, the thing that they can earn extra due to the training is equal to 3. For the always takers, who are very eager and they will also work very hard in the training, this extra effect on their earnings from training is going to be equal to 4. And for the never takers, the effect is only going to be 1. Yeah, because these people are not going to be very enthusiastic. So even if they take the training, and actually they won't, but even if they would take the training, the effect would be 1. And gives me the fraction of these different groups. So half of the people here are assumed to be compliers, 25% are always takers, and 25% are never takers. So the function that we're going to use is accept, and accept is a dictionary. So if I call accept with complier as key, it returns the function accept complier that we defined here above. That's going to be this function. If I call accept with the key always taker, it's going to be the function accept always. This is the function that we defined over here. And finally, if I call accept with the key never taker, it's going to call the function accept never, and accept never basically returns always 0. Yeah, so in Python you can have a dictionary that returns functions, and then we actually call that function. So we're going to keep track of the information that we have on earnings without training. We're going to keep track of the training effect that we're going to see. We're going to calculate earnings, which is basically the sum of these two. We keep track of who was invited and who was not invited, and of who got training and who did not get training. And then we're going to define df as our data frame that we're going to be working with. Yeah, so PD is a pandas data frame. So we're going to generate our data by calling this function data simulation. Yeah, so here later on we call this function data simulation. And this function returns a data frame. So we say our data frame is equal to the data frame generated by data simulation. We have no arguments here because the way we define the functions we already give default values. Yeah, so if you don't give any arguments when we call the function, beta is going to be equal to beta, which is this dictionary beta over here. Tau is going to be equal to tau, which is the dictionary over here. And n is going to be n, which is the dictionary over here. Yeah, so later on if you want to play around with this, the data frames that you can generate here, you can choose that, you can write beta is equal to a different value of beta. And if you don't specify tau or n, it will simply choose the default values for tau and n. Yeah, so it's very simple to generate different data sets with different assumptions on the effects or the fractions of the different groups. So what does this function do? This function loops over the different types. Yeah, so when we start, the first type is going to be complier. So first we run through this code with j equal to complier. So then we calculate the earnings without training for compliers, and that's going to be drawn from a random normal distribution, where the mu of this distribution is going to be beta complier, and beta complier, that's a dictionary, is going to be equal to 1. Yeah, so for the first iteration over types, we look at complier, and that means that the mu, or the log in this case, is going to be equal to 1. In all cases we assume that the standard deviation is equal to 1 as well. And the size of these draws, so how many draws I take from this normal distribution, is determined by the fraction of compliers, which in this case is half, times the number of simulations, which was 10,000. Yeah, so this needs to be an integer. So just in case I call this integer here, because if you start playing around with n, you might end up with 335.345 as a size here, and that will throw an error. Yeah, so in this case the integer is not needed because I've chosen these values carefully, but if you later on start playing around with different fractions for the different types, it's prudent to have this int statement here, which basically will turn this thing into the integer that's just below the value that's given here. So that's how we determine for each individual complier what the earnings will be if the person does not get training. We do a similar effect here for the training effect. So again, it's going to be a normal distribution that we draw samples from. For this case, the mu, or the location, is going to be given by tau. So that's this dictionary tau here. In the first iteration, that's tau for complier, so that's going to be equal to 3. So this is we're going to be drawing here from a normal distribution with mu 3 and standard deviation 1. To generate invited, I'm going to draw from a binomial distribution, so that basically draws zeros and ones. The fraction of ones that is going to draw is going to be determined by this fraction training, which we set before at 0.2, so at 20%. And again, the size, so how many of these we draw, is given by this, by the size of the group compliers. Now, to determine whether somebody got training or not, we have trained here for compliers. That calls the dictionary accept with the key complier. So if you call accept with the key complier, you basically call the function accept complier. So this function accept complier, the one that we have over here, is called with the argument invited complier, which we generated in the line before. Yeah, so that will be a factor of zeros and ones, depending on the outcomes of this binomial distribution here. Then finally, the earnings that each individual is going to get, each of the compliers is going to get, is the earnings that it earns without training, plus this factor whether or not he got trained. So if trained is 0, the person did not get training, and there is going to be no further effect. But if trained is going to be equal to 1, this training effect is going to be added. Yeah, this training effect, we generated ourselves here. That's a factor of draws from this normal distribution. So now to generate our data frame, we're going to create columns for each of the variables that we're interested in. And basically what the column does is it concatenates for each variable. So here for the invited variable, it puts together the vector invited for each of the types that we have. Yeah, so first you loop through types and that it's complier. Then in the second round that you loop through these, it's going to be the always takers. And the third time you loop through this code over here, it's going to be the never takers. So here when I'm going to fix the column invited, I'm going to glue these three different outcomes of invited together into one long column. Yeah, so I glue them together along x is equal to 0. That means I glue them together along the rows. Yeah, so it's going to be one long column vector. So here I have trained. Trained is a dictionary with 3 vectors in it, and again column trained is going to glue together, concatenate these columns for trained together along the rows. And finally the same for earnings. So then I define my data frame using the function pandas data frame, The first variable in this data frame, or the first column, is called invited, and it consists of this column invited that I just determined here. The second column, or the second variable in this data frame, is trained, and the final variable is the earnings that were actually earned by each of the individuals in our sample. So then I can print the head of this data frame, and that's the one you can see over here. So it happens to be the case that the first 4 individuals were not invited for training. Since these are all compliers, they indeed did not get training because they were not invited. But the 4th one, or actually the 5th one, so the one with index 4, he got invited because he's a complier, he got trained, and here we have the earnings of this trained individual. Yeah, so we standardized all these effects, so earnings can be negative. If you're bothered about this, then think of this as the log of earnings.